Welcome to this class on the demand forecasting. As you might recall, we are approaching the general theme of the investment process, market and marketing, and this is the first part of our module of this program. We will deal with a very rich outline, so we'll see a lot of contents related to the statistical techniques for exploring demand forecasting. We will start with some general considerations. Then we will proceed through the description of various models in general terms. Then we will focus on the description of a representative sample of methods. Finally, we will deal with the concept of elasticity of demand. Let's start with our general considerations. When it comes to demand forecasting, we should start from the general question about what forecasting is. So forecasting is a very traditional activity for the human beings. I mean that since the very old ages, the humans have tried to forecast the future, to foresee the future. In strategic terms, forecasting is related to the fact that whatever company needs to understand what are the general trends about the past that could be considered stable or recursive for the future. So forecasting is needed in order to face the future competition and the future environmental pressures in a more aware way. Issues in forecasting span from statistical bias to the opportunity or the employability of such techniques in a real-life context. We will deal with the models because according to the models that we use, we might have different results, so the expected output should be a better decision or a more effective decision. According to the model we pick, we might have different outputs in terms of support to such decisions. Then we have the issue of forecasting demand and sales. So as we will see momentarily, the company is forecasting demand since the project implies to sell some products, goods or services to a specific market. So it's not just about forecasting the general demand, but it's also about estimating the sales share of the company. So when it comes to the applicability, considering all these elements we've faced so far, it's pretty understandable that forecasting is applicable whether some specific conditions underlying and the potentiality of such items could be put into place. So let's start with the definition of forecasting in a more precise way. In the context of project development, forecasting is an attempt to predict both demand and sales. So, although we will focus on demand conditions, the general outcome is to produce an estimation, an accountable and reliable estimation of sales. Let's face with the issues in forecasting. The first issue is related to the purpose of forecasting. So forecasting could be related to different activities in a company. In the simplest way, we might say that since the project or whatever initiative aims to sell products, goods, or services, forecasting could help the company predict in a more efficient way and in a more effective way what the demand that the project could serve could be. Second, we have different factors related to forecasting. One factor is related to the utilization of qualitative or quantitative methods, as we will see in a few moments. Or to go through an hybrid solution, which is the combination of both quantitative and qualitative methods. Another important aspect is about accuracy of forecasting, meaning that according to the time span that we consider for our decision process, some methods and forecasting techniques and tools are more effective for the short-run predictions, whereas some other techniques give better answers when it comes to the medium or long-range extension. So, in the short term, we might refer to some methods. In the long run, we might refer to other methods. Another issue is related to the consequences of not forecasting. So, despite the consideration that forecasting could not help the company face any kind of possible future situation, renouncing to forecast could put the company and the project into troubles when it comes to predictable issues. So it's very important, for example, to satisfy all our stakeholders with accountable predictions, since in case of misleading results, the company and or the project could be blamed for inaccuracy in forecasting. Descriptions of various models. As we've seen already, forecasting implies the utilization of some models. Just to recall the idea that we already mentioned, though these models could be based both on qualitative and quantitative methods, or they could be the combination of both of them. A model implies that we're facing with some variables, and we will distinguish between dependent and independent variables. So we will try to predict a dependent variable, let's say the sales or the market share, according to the values that the independent values are assuming. When it comes to demand forecasting, we consider the independent variables related to the time, for example. So this scheme could help us define and explore different methods and approach we might consider in dealing with forecasting. So we have four main groups: judgmental methods, compilatory methods, quantitative methods, and technological methods. And we have some subgroups for the two main boxes represented here, the judgmental methods and the quantitative methods. So we will deal with all these methods in details, but just to give you a rough idea of what we're dealing with, we might consider the judgmental methods as the result of the judgment both from individual and groups. Then we have the compilatory methods, when the compilation of data about one variable is called and used for forecasting demand. We have several quantitative methods, as we will see, and these quantitative methods could be classified into self-explanatory methods, when we have one variable which is related to time as independent variable. We might have explanatory methods when we have different variables included in the estimation of the sales level. Then we have the monitoring methods when we have the tracking of a specific phenomena that we consider closely related to the sales phenomenon. Then we have technological methods, which is employable in specific industries whereas technology has a crucial role for the competitive dynamics. So, with technological methods, the future development of technology is considered the main driver for estimating demand and sales for the project. Let's start with the judgmental methods. When it comes to judgmental methods, referred to individuals, we might have judgment and scenarios. So, judgmental methods could be considered as a combination of qualitative and quantitative methods, to the extent that it's not just the judgment of individuals, the ideas of individuals, which is helping us forecast the demand, but it's also the utilization of some quantitative data. So, individuals make the hypotheses which are underneath the selection of different data sets. According to the data set that I'm going to pick up, I can have a different scenario. So a scenario is made of quantitative points, data, and hypotheses on the range of alternatives that as an individual I might have in facing the future. When it comes to groups, we have the committees. So committees is a social entity by definition, so it's made by 2 or more people. And within committees, we have group dynamics as well. So the so-called politics of the organizations could take place in the decision process. We might have the sales forces estimates. This is another crucial element. Sales forces, sales personnel are a very important source of information related to the market and its potential development. So, sales force is a pressure asset for whatever company serving a market. Their information might be very accurate and very specific. Then we have juries of executive opinion. When it comes to executive opinion, the locus, the preferred locus is the board of directors, which is the main element of governance of whatever company. So the executives, the directors, could express their opinion about the future development of demand. Then we have the Delphi method. The Delphi method is a very complex method. In short, the Delphi method is based on a panel of experts which are interviewed by a questionnaire. And these questionnaires are delivered in different phases. The characteristics of the Delphi method are based on the fact that the next step questionnaires are based on the results of the previous step. So we might have a first round of interviews or a confrontation among all these experts. And then the outcome of such a meeting or such a moment of confrontation is the input for the next stage. So we have a dynamic development of questionnaires based on the exploitation of a panel of experts, based on the ideas, confrontation from a panel of experts. Then we have the compilatory methods. So we're switching to the second box that we just seen. Compilatory methods is the compilation of data on a specific variable, just to recall the idea. And the user are crucial in the compilatory methods. So we do not interview the sales forces as in the judgmental methods. We interview the clients, for example. So the final users of the product. We might consider some consumption coefficient as well. This is an industrial study. It's an industrial way of forecasting demand. So just to give you an example, as you might find in your materials, what is a coefficient? If we consider the number of houses which is built in a specific location, and we consider some components for finishing the houses up, like doors or windows, according to the number of houses which have been built, we might estimate a coefficient of the doors that we need for a house. So if on the average each house is requiring 4 doors, the coefficient is 1 to 4. Compilatory methods could be market build-up as well. So if we consider the demand expansion, if we observe the market in general terms, we might assume that the target or the segment of market which is of interest for our product could be traced and predicted according to the general conditions that we might find in a specific market. So it's called market build-up method, since it's starting from the market analysis in general terms. When it comes to the technological methods, we might have different approach. The first approach is related to system dynamics. So if we consider the industry as a whole, as a system, we might explore the different forces influencing the different sub-elements, the subsystems of such a comprehensive system. So when it comes to prices, demand expansion, and so on, if we study the industry as a system, we might be able to estimate the future demand. Another approach is to refer to the so-called morphological research. So the characteristic of morphological research is to focus on the structure of a system or whatever entity rather than to the function of such an entity or system. Which means that, in short, technological methods could be related to the structural analysis of the main forces driving technological innovation in a specific industry. Then we have the cross impact. If we consider different segments of the same industry, and or if we consider the degree of correlation among different related industries, the study of the connection and the links existing between the industries could be an excellent source for the demand forecasting as well. So, considering that different industries might be exposed to different life cycle stages, as we've seen already during the market demand analysis, we might consider the previous or the first mover industries as an explanatory phenomenon helping us estimate or forecast the future demand. Then we have the trend extrapolation. The extrapolation is a statistical method for extracting some future points in a graph. Statistically, we consider the trend of the past, and we consider this trend as a stable pattern for the future development. So if we consider the previous technological innovation trends, and we do not consider any technological shock or revolution as possible, then we could extrapolate the trend considering the previous situation. When it comes to quantitative methods, we might have basically 3 alternatives, as we've seen already. We have the self-explanatory method, when we have one dependent variable and one independent variable, and the independent variable is time. We could have the explanatory methods when we have one dependent variable and several independent variables which are time related. And then we have the monitoring, considering the tracking of a phenomena and the study and the collection of all these data related to the specific phenomenon and its trends. A little focus on the self-explanatory methods. Self-explanatory methods could be of different kinds. So we might have the naive one, which are mostly based on the investigators' skills, on the analyst's expertise. Then we have the simple time series, which might be discrete or continuous. So again, we have one dependent variable, one independent variable. The independent variable is time. In the simple time series, we have a pattern which is driven by time and has its impact on the dependent variable. Time series could be decomposed as well in different sub elements. So if we decompose a time series into different parts, we might consider different average values for each stage of the series we're considering. Another way for forcing the distribution of the average values is to utilize the exponential smoothing. So as we'll see, the exponential smoothing is used for giving higher weights to the more recent data. Then we have the advanced time series. So when it comes to the advanced time series, it's the same idea of the simple time series, but we have different variables, and all these variables are time related. Let's focus now on the description of a representative sample of methods. So let's focus on some specific methods, the most diffuse ones. Simple time series, STS, is one of the most diffuse methods for demand forecasting. So it might be graphical, and it is graphical when we have a plot depicting on the abscissa axis, the x-axis, time, and on the ordinate, the y-axis, we have the expected demand. So graphically, we could reconstruct the time series by associating different values of the dependent variables to the time extent that we're considering. So graphically, we could have some trends which are they could be very effective to be depicted. Growth rate is another approach to demand forecasting. It's a more statistical way for determining coefficients or trends or functions explaining on one hand the dependent variable and the link with the independent variable. Statistically, we have regressions when we employ the least square methods. So the assumption is that if we have different points, data points, we might reduce the square distance between these points and the mean and the median of the distribution. Our general caveat is about the application of the simple time series method. So the general hypothesis is that we might use the graphical, the growth rate, the regression methods only if we consider the future trends as related to the past ones, and only if we ignore the hypothesis of a sudden shock in the conditions explained in the previous the past trends. So, for example, a sudden change in clients' tastes could be a shock for the demand. It could render the demand forecasting based on the time series totally ineffective. Regression for simple time series. So we have to collect time-based data for the variable. So if we consider the overall sales and we try to refer to the simple time series method, we should collect the values of this variable during the time extension that we're taking in consideration. Second, we have to select a mathematical form for the trend, for y being function of time. So this formula is crucial for the demand forecasting, and according to the shape, the graphical shape of this function, we might be more or less accurate in predicting future trends. Then we have to apply the regression to data to determine the coefficient. So once we have established the function here, then we have to estimate through the regression the coefficient, linking the time to the dependent variable. And then we have to find the confidence intervals. The confidence intervals, in short, might be defined as those intervals that could explain the accuracy, the statistical accuracy of our predictions. Time series analysis, when to apply. Again, we're recording some ideas we dealt with already. Time series analysis could be applied when the demand determinants are difficult to identify. So, when companies or project analysts do not have specific, accountable, and reliable information about the demand conditions, the only thing they can do is take the past evidences and try to foresee what the future might be in terms of sales for the company, for example. Second, we have historical data which are available and relevant. So another condition is that we might have at our disposal a data set which is time built or time explorable. Third, we have trend or cyclical pattern existing. So when we have previous trends, or we might be able to detect cyclical patterns, then demand forecasting can be based on time series, even on the simple version. Again, when market perturbation, when market shock are improbable. So if the probability of a cultural shock, or technological shock, or market shock, radical change in consumers' tastes, the probability is very low, then time series could be employed for forecasting demand. As we've seen, time series is not the only diffuse method. Another one that I've recalled already is the exponential smoothing. So the effectiveness of the exponential smoothing is the fact that most recent data in time series are weighted more heavily. So the idea is that, contrarily from the simple time series method, with the exponential smoothing, the data points do not have the same weight. So the idea is that more recent data could be considered more accountable for the company, which in turn could imply that the decisions based on more recent data could be more effective for the company and the project. So in formulas we have to have this exponential smoothing applicable for short-term forecasting. So again, the idea is that if we consider the recent data as more important for the analysis, that implies that we have a short-term orientation of the analysis and the decision themselves as well. So we have weight for past periods. So we might consider the weight in this formulation, alpha times brackets 1 minus alpha, and the exponential is t, time. So t is the number of periods before the present. So this is the past. And of course, by formulation, the sum of the weights equals roughly to 1.0. So the idea again is that we give a higher weight to the more recent data. So if the exponential is existing here, is increasing here, then we have different weights related to different times related to different data points. So the exponential smoothing is quite diffuse when it comes to the short-term forecasting. Explanatory models are quite diffuse as well. So they are mainly based on statistical techniques. The first one is the simple correlation. So again, we have two variables. One is dependent, the other one is independent. The simple correlation is determining the relation between the linear simple relation between the dependent and independent variable. Then we have complex correlation when we have one dependent variable and more independent variables. The econometric model is a solution which is combining different correlation techniques or other statistical methods in a formula which is comprehensively trying to explain the relation between one dependent variable of different natures and one or more dependent variables of different natures. Another model is the input-output analysis. So if we consider the inter and intra-industry relations, we might focus on the inflows and outflows from one segment to the other, or from one industry to the other, in order to estimate all these flows as determinants of the future demand. Multivariate methods could be based on correlation as well, and or could be expressed in an econometric model. Multivariate methods are used for hypothesis testing. So if we have an assumption, we could transform this assumption into an hypothesis, and the hypothesis could be tested to the multivariate methods. In this context, we might have the analysis of variance, the ANOVA, as a powerful tool for analyzing the accountability and the general probability that the estimations could be considered consistent with the previous trend and the general situation. Then we have simulation. Simulation is the idea of having a model connecting different variables, and the links between these different variables could be considered as stable, and changing the levels of inputs, we might have different results in terms of outputs. So it's a pure simulation which is related to demand forecasting. Then we have the idea of elasticity. So, but the last one we will have a specific focus on. So when it comes to explanatory models, we might have all these alternatives, and by referring to one of these methods or to a combination of these methods, companies might be able to define the future demand, to estimate better the future demand. So let's conclude with the idea of elasticity. The concept of elasticity of demand is based on the fact that elasticity itself is the measurement of sensitivity of one variable to changes in another variable. So the assumption here is that we have at least two variables, and we estimate the elasticity as the variation in the levels of one variable related to the change on another variable. So when it comes to demand elasticity, we consider the demand as one variable and another variable as the driver of such a sensitivity. So the idea of sensitivity in changes is central to the idea of elasticity itself. When it comes to demand forecasting, elasticity could be referred to the price of the product. So according to the fact that the price is rising or lowering down, we might have different reactions in the demand. So for traditional goods or products, as the price goes down, the demand should increase. The income of the actual and potential customers is another driver of elasticity of demand. So as the income again rises or goes down, we may have effects on demand of our products. Cross elasticity is quite important as well. Cross elasticity is linking two or more products. So if we consider two substitutes, for example, train and airplanes, or cars and motorbikes, if they satisfy the same need of a specific target of the market, changes in the price of one product could impact on the demand of the other product. So if trains are becoming more expensive, probably people might prefer to use the airplanes instead, or the other way around. The last form of elasticity, which is crucial for the demand analysis, is the promotional elasticity. So the promotional elasticity is related to the promotion of the products. And since promotion is the effort that companies are making in order to launch the product or to penetrate a new market, the reaction of customers to these attempts of penetration is called promotional elasticity. So that's everything for today. We have dealt with the idea of demand forecasting. You can refer to the materials and to our website for further information. Thank you.